So I have the square root of x plus 15 equals 5 plus the square root of x. So that looks very similar to the one we just did. So we already have one of the radicals isolated, so I'll go ahead and square both sides, which means I do have to do a binomial squared on the right side. So these will cancel out. The square root cancels out with the squared, so I get x plus 15. And I will need to double distribute this side. So 5 plus the square root of x times 5 plus the square root of x. 5 times 5 is 25. So that's 5 times 5. 5 square root of x plus another 5 square root of x. And square root of x times the square root of x is just x. And that gives me 25 plus 10 square root of x plus x. And that equals that x plus 15 that I already had on the right side, or the left side, I should say. Now we're going to isolate the radical on the right side by moving things over to the left side. So I can subtract 25 from both sides. So x minus 10 equals 10 square root of x plus x. And then I'm going to subtract x from both sides. So that cancels that out. So I get negative 10 equals just going to be 10 square root of x. Then divide both sides by 10. So that'll be negative 1 equals the square root of x. Now finally I can square both sides, and I will square the negative 1. Since I'm squaring negative 1, I need to put the negative 1 in parentheses to show that I'm squaring the negative as well. So that gives me 1 equals x, because negative 1 times itself is a positive 1. So we should check our answer. So I'm going to replace the x over on both the x's with 1. So that will give me the square root of 1 plus 15. Does that really equal 5 plus the square root of, and replace that x with a 1. So 1 plus 15 is 16, so that's the square root of 16. Does that really equal 5 plus, the square root of 1 is just 1. The square root of 16 is 4. Does that really equal 5 plus 1? And it definitely does not. 5 plus 1 is 6, and that is not the same as 4. So we have another extraneous solution, and since it's our only solution, that means that we actually do not have a real solution to this problem. So there are no solutions. But remember, you do need to check every time and check all the solutions that you get just to make sure that maybe one of them works and one of them does not. So now let's use these techniques to do a word problem. The time t in seconds that it takes a pendulum to make a complete swing back and forth is given by the formula t equals 2 pi times the square root of L over G, where L is the length of the pendulum in feet and G is the acceleration due to gravity at 32 feet per second squared. We'll do both of these parts. So starting with part A, in Tokyo, Japan, a huge pendulum in the Shinjuku building measures 73 feet 9.75 inches. How long does it take the pendulum to make a complete swing? So we're definitely going to use the formula t equals 2 pi times the square root of L over G. So we do know some of the things that we can plug into this problem. We're trying to figure out how long as it takes for the pendulum to make a complete swing. So the variable we're solving for is t. Of course, pi is going to be 3.14 or whatever your calculator uses for pi. I'm not going to replace that quite yet. But we need to think about what L is. L stands for the length of the pendulum in feet. But the information they give us about the pendulum is that it's in feet and inches. It says it's 93 feet, 9.75 inches. What that means is we need to take the inches portion of that, the 9.75, and change that into feet. So we would do that by off to the side or on your calculator. You would need to take 9.75 divided by 12. And when you do that, you get 0.8125. So that's what part of a foot 9.75 inches is. So 73 feet, 9 3/4 inches would be 73.8125 feet. So that's what we're going to replace in for the L, is that 73.8125. And then we're going to divide that by G. Well, what's G? G, it says, is 32 feet per second squared. Now, that doesn't mean you're going to take 32 to the second power. Per second squared is actually the unit of measurement. We're just going to replace the G with a 32. So there's your replacement step. So we need to do what's inside of the square root part first. So that will be T equals 2 pi times the square root of whatever 73.8125 divided by 32 is, and that equals approximately 2.307 if I round that to the nearest thousandth. Then I'm going to take the square root of that, and since it's already in your calculator, you could just simply, whatever's in your calculator, take the square root of it, and when you take the square root of it, you get about 1.519. So now you have 2 times pi times 1.519 or whatever's on your calculator screen. And when you multiply all those out, and it always depends on what you use for pi and what you're rounding to, you get approximately, if I round to the nearest tenth, about 9.5. So we get T about 9.5. And what is the label? Well, T is time, and it says in the original problem, if you look up there, the time T in seconds, so I should label that in seconds. So that's part A, 9.5 seconds. Part B says a clockmaker wants to build a pendulum that takes 20 seconds to swing back and forth. How long should the pendulum be? So we are going to use that same formula, that T equals 2 pi times the square root of L over G, but this time we're trying to figure out how long the pendulum will be, so we're going to actually try to figure out L. This time we know what T is. It tells us he's trying to build a pendulum that takes 20 seconds to swing back and forth. So this time we'll replace the T with 20, and that's going to equal 2 pi times the square root of L over, and remember G was 32 feet per second, so squared, so that would put 32 feet in for the G. And now we're solving for L. So we're going to use the process that we did on the problems to start this lesson, is that we're going to start out by getting the radical by itself. So we're going to isolate the radical, and the first thing I'm going to do is I'm going to divide by 2 pi on both sides. So you'll take 20 divided by 2 pi, and again, depending on what you round to, you get approximately 3.18. And again, you might get something a little bit different on your calculator. I was using 3.14 for pi. You might be using the pi button. Either one is okay. So that's going to be approximately equal to L over 32. Now I'm going to square both sides. And when I take 3.18 or whatever's in my calculator and square it, I get approximately 10.14. So that is about equal to, since those canceled, L over 32. And then I will square both sides, or take both sides times 32, not square both sides. So both sides times 32 will give me my answer for L, about 324.6 is what I come up with, about 324.6. So this was a square root equation where I did have to square root both sides, so I better check my answer on this one. So again, going with the original problem here, and the original problem was 20. Does that really equal 2 times pi times the square root of that 324.6 over 32. Now, I did do some rounding on this one, so I may not get exactly 20, but I should get something pretty close to 20. So I'm going to have to take 2 pi times whatever the square root of 324.6 divided by 32 is. So that gives me about the square root of 10.144. So when I take the square root of that, I get about 3.185. So does 20 really equal 2 pi times 3.185? So I need to take what's in my calculator times 2 and then times pi. And when I do that on my calculator, I actually get this. I get 20.000, then it goes 1331. But I did some rounding, so that is pretty close. So I'm going to go out on a limb and say that, yes, this is the correct answer, 324.6, and that is a very long pendulum because that should be measured in feet. So it's 324.6 feet.